video guides you through how to simplify surds and then how to rationalise a denominator. These are examples of surds. They are multiples of the square root of n, where n isn't a square number. They are irrational. They are very useful to use to write answers in exact form. So watch out for questions asking you to write exact answers. Here are the rules of surds. Note that you can only combine when you're multiplying or dividing. If you're dealing with something like this, you can't combine them. But obviously, if you've got something like this, then that does combine. Okay, let's do some simplifying. Let's take the example of the square root of 18. Okay, so we'll use the multiplication rule to split 18 up into 9 times 2. So we need to be finding factors to split our original number up, but these factors have to include a square number. Okay, because when we continue, you can see that we know the square root of 9. So we can simplify this to 3 root 2. Okay, let's have a look at another example. Square root of 75. So we need to look at a square number factor of 75. And that is 25. 75 is 25 times 3. Split that up. We know the square root of 25, which is 5. Square root of 3 stays as it is. So we've simplified it as much as we can. Okay, let's have a look at another one. Square root of 42 over the square root of 7. Okay, according to the rule, we can simplify that to that. We know that 42 divided by 7 is 6. So that's root 6. Okay, root 6 is as simple as it gets in terms of surds, because there's no square number factor to take out. It's not a prime number, so there are factors, but none of them are square. So that is as low as we go. Now let's do some bracket expanding involving surds. So we expand these brackets just like we do any other double bracket. So 3 times 3 is 9. 3 times minus root 2 is minus 3 root 2. Root 2 multiplied by 3 is 3 root 2. And then root 2 multiplied by minus root 2, which is minus. So 2 times 2 is 4, so square root of 4 is 2. So we have that. So we can see that that cancels out with that, and we're just left with 9 take away 2, which is 7. So this is deliberately chosen, this example. When we have a number which is written as an integer plus a surd, and we multiply it by the same integer with the opposite sign in front of the surd, we can see that this results in just an integer with no surds. So that's going to come in handy for the next stage. This leads us to rationalising a denominator. So that means getting rid of a surd in the denominator, or turning the denominator rational. We have this fraction with a surd in the denominator, so to change this to a situation where the denominator hasn't got a surd in it, we have to basically multiply it by 1. Okay, but not one straightforward 1. We need to multiply it by a fraction with the same numerator and denominator. Okay, and as we've seen in the previous example, if we use this as the denominator, obviously the numerator has to be the same because we said we're multiplying it by 1. We can multiply anything by 1 and expect it to stay the same. Okay, if we do this, then we know from the previous example that when we multiply this out, it's going to turn into just an integer with no surds, which is what we're aiming for. So let's have a look at that in action. Okay, so 1 multiplied by 5 minus root 2 is just 5 minus root 2. Okay, so multiplying the denominators out. So 5 times 5 is 25. 5 times minus root 2. Root 2 multiplied by 5. Root 2 multiplied by minus root 2. Minus 2. Okay, so these two cancel out, and that leaves, that is the answer, and that's got no surds on the denominator. So we have rationalised the denominator. Here's a question for you to have a go at. Feel free to pause the video, and when you turn it back on again, I will explain how this goes and what the answer is. Okay, so the first step should have been for you to multiply out the denominator. When you did that, you should have made that this. Okay, next stage is to rationalise the denominator. So that means multiplying by this, multiplying it out and simplifying with, and cancelling down would then lead to that. So that is your answer. I hope you found this video useful. Thank you very much for watching.